On this video, we're going to be doing the work on it activity on page 112 and 113 from your book. You're going to experiment to find out which materials allow electricity to flow through easily and which materials stop the flow of the electrical current. Follow the procedure to complete the experiment. Collect your data by creating a table and answering any questions that are asked. So if you weren't able to do the experiment, you could watch this video and use the results from it to fill out your table. The materials you'll need: one metal spoon, we're going to substitute a wrench for that, one piece of wood, one quarter, one pen, a 6-volt battery or D cells. If you're using D cells, you would use 4 of them, since each of them are 1.5 volts each. 1 glass of water, 1 glass of salt water, 1 LED light emitting diode, 3 wires with alligator clips, each wire about 30 centimeters long. On the shelf in the storage room, I do have some LED bulbs. If you want to use that, you'll get much better results using LED bulbs than the old incandescent I have in this one. Because of it being incandescent, some of the results might not be that great, because there will be energy flow, but it might not be enough to get it to light up. But we'll just see how things go. Okay, procedure number 1: to test which materials will allow electricity to pass through them. You'll need to construct an electrical tester, examine the materials available, and brainstorm your next step. So for my electrical tester, I'm just simply using the light. So if the light comes on, that shows that there is electricity flowing through. 2, connect one end of the wire to the positive end of the battery. Connect another wire to the negative end. Use the wire connected to the positive end and connect it to one of the LED metal ends. Take a third wire and connect it to the other metal end of the LED. Your tester should now have 2 free wire ends. In your notebook, make a table to list the remaining materials for testing. Add 3 blank rows below the last listed material. These rows will be filled in later in the experiment. Add 2 columns beside the list of materials. Label one column prediction and the other observation. Okay, so for the purpose of this experiment, Brooke is running the camera, but I'll let her make the predictions. So Brooke, your prediction for the metal spoon, aka the wrench, what do you think is going to happen?
I think that the electricity
Electricity is going to
flow through.
Okay, so Brooke is believing that this is a conductor. So I'm going to hook up the negative on this end, and I'm going to hook up the negative on the other end. So yep, you can definitely see that the light is on. The wrench is a conductor. Okay, so that one works. The next one we're going to hook up is the piece of wood. Brooke, what's your prediction on this one?
I think that the electricity will not flow through.
Okay. So we'll hook up both of the negative ends to it. The light does not come on. Okay, so it is a poor conductor of electricity. Okay, next one is a quarter. Just a regular quarter. Brooke, what is your prediction for this one?
I think that it will flow through.
You think it'll flow through? Okay, good prediction. Yep, a quarter is a good conductor. Okay, our next item will be a pen. Oops. And it's a high quality pen, Mr. Bell's favorite. Okay, Brooke, what's your prediction?
I think that it won't work.
You're right. The plastic acts as an insulator. It will not conduct the electricity. Okay. Brooke, what do you think for the glass of water?
I think that it will work.
You think that it will work, okay? So I'm just going to put these U's in here so my ends aren't getting wet. So I'm going to hook up the one on this end Gonna hook up the other on this end. Okay, no light on here. So Brooke, can you shine on that? Now, one thing that I wish we had was an LED, because the water will act as a conductor. Definitely not as good as metal, but it will work as a conductor. So if you do this with an LED, you can get one from electronics kit or off the shelf on the right hand side in the storage room. You will probably get a positive result. Now, do we have any light coming through there, Brooke?
Nope.
Doesn't seem to be a strong enough current to get that filament going. Okay, so Brooke, the next one, what is your prediction for salt water?
I think that it will work.
Okay, let's hook those up. Okay, now take a look at this. Now look at the light, Brooke. No light, but take a look at what's happening in the water. Can you see the bubbling coming up? So that definitely indicates there's a flow of electricity going through. There's some gases being created. Okay, I'm just gonna take that out. Now, you can see that this salt water is very murky. I actually have another glass of salt water, same amount of water pretty well, same amount of salt pretty well, and it's definitely changed. You can see that there has been some type of reaction in that water. Maybe we could ask Megan to maybe tell us what she thinks might have happened. This would be kind of similar to her science fair experiment. You probably won't get something like this happen when you do your experiment. The water I'm using from, or for this experiment, is actually from a well with a great deal of iron in the water. So I don't think you'll get it from your tap water at the colony, since it is processed at a filtration plant. Okay, so if you want to carry on with this on your own, you can do so. You can find different things to use. Just make sure you're being safe. You don't want to use a 12-volt battery. That has too much voltage coming through. A 12-volt battery can actually kill you. Okay, so thanks a lot, guys. Good luck. Hopefully you can get some similar results or even better results than I did.